So after we studied the elements for the quiz on Tuesday, the non-honors class is taking this on Wednesday. They're about a day behind. So I'm going to tell you that right there. There you go. All right, so what I want to do is show you a real quick, very quick video, very small video. And I'm going to try to get you involved in who this person is a little bit. Are you ready? Yeah, you want to do that? Okay. There are two light switches here and here. If somebody wants to do that. Thank you. Okay, this is only about 5 minutes long, so whoops. Okay, there it is. Close that door. I'm sorry. I know you guys were never like that, so right?
No.
Middle school. No.
We were not that friendly.
very short, and here we go. The kind of a short video there, and you say, well, what are we studying this person? And I have a book here, and this is a book, I know you've all read this book, and it's called The Chemical History of a Candle. Have you read that? No, I didn't think so. I remember seeing this book probably about, I don't know, more than 25 years ago, maybe 28. And I thought, what kind of dumb, that's a dumb book. Who would read a book like that, you know? And so I picked it up and I started looking at it. And I didn't even remember. I remember somewhere in the back of my mind, Faraday, I don't know. I didn't know that much about him at all. And I started reading this. This was like, wow, what? He's doing all this stuff. He's trying to tell you how many experiments he did just to study on a candle. And he made a statement. It's in your handout sheet. I'll go ahead and show you on the board, though. He made a statement. It's right here, and I'm going to keep that on the board. Every day we're doing the lab. And it says, there is no scientific law under which any part of this universe is governed, which does not come into play and is touched upon in these phenomena. There is no better, no more open door by which you can enter the study of science, not your philosophy, is what they called it, than by considering the physical phenomena of the candle. That's a pretty strong statement. He's saying pretty much everything I know about science there back then, you could find it in a candle. It's there. There's some physics in the candle. There's chemistry in the candle. And that's a pretty powerful statement. The other thing that really intrigued me was of all the stuff, and I'm going to try to tell you some of the things he did. He did so many things. He invented so many things. But he also had time. He thought he wanted young people to be curious, and they wanted to go into science. And he had these things called Faraday's Christmas lectures. And he would take people, young people, teenagers, and even younger, and he would bring them to this place in London, the Royal Institute. Was associated with the Royal Society, and this is where all the famous scientists gave their lectures and things. And he would bring them here at Christmas, and for day after day, he would do lectures and demonstrations about the candle and try to get them to maybe go home and think about it like that. And I'm going to have you read it. You can look online, Faraday's Christmas lectures. You can find some of these and what he did. But we're going to try to recreate at least a situation where you're going to be studying a candle and you're going to be an experimenter. There's another person said that I think it'll be conceded that Michael Faraday was the greatest experimental scientist that the world has ever seen, and the progress of future research will tend not to dim or diminish, to actually enhance and glorify the labors of this mighty investigator. I do consider him to be one of the greatest experimental scientists I've ever read about. So that's what I want you to do. I want you to become not Michael Faraday, but I just want you to become an experimental scientist at this point. There's so much stuff in the book. Yes, we have stuff in the book we have to learn. And that's fine. That's from stuff that people discovered a long time ago. But I want you to be able to have a chance to discover some things. And even though I've done the Candle Lab for over 30 different years, every single year I have students who will show me something I've never thought about. God made every one of you different. And some of you are going to show me even this year. You're going to probably show me something I've never thought about this year. And so anyway, that's what we're getting ready to do. Now, in order to go a little further with this, I want to show you about Michael Faraday. So go ahead and get your handout sheet out, and we'll talk to this. Well, I don't know if I'm going to use that or not, but Michael Faraday is somebody who actually had very little education. That's kind of weird. He stopped school at 13. Okay, now what are you going to do? Well, he could become a blacksmith like his dad, but he already knew his dad didn't make a lot of money. They were pretty poor. The dad moves to London to get some more work, and there happens to be a bookbinder. Bookbinders were people who write papers, and they said, can you put a cover on it and make sure it looks like a book, you know? So he was an apprentice to be a bookbinder. What difference does that make? Well, he was allowed to actually take those books home, and he read them. And he read all kinds of books. And he was just curious. Remember that video? It said curiosity? He was curious about things. So here's somebody who had very little education, but he was curious. And he read about some lectures, and you'll hear about this guy named Sir Humphrey Davy, very big in chemistry, very big chemistry name. Anyway, he went to a lecture of his, and he was just enthralled. And he would take notes. I don't know why, but he took notes on all of it. And he went back to his bookbinder and actually had 300 pages of notes from Sir Humphrey Davy's lectures. And he put them in a book form. And Humphrey Davy was very impressed. He said, well, thank you very much. But you know who you are. You're the son of a blacksmith, and you don't really belong with us. So in a way, he kind of dismissed him. Then later, Humphrey Davy had a little accident, and part of his eyesight, he lost part of his eyesight. And so he knew he had to have an assistant to help him. So he picks this guy, Michael Faraday, and he becomes his assistant and his lab assistant. And Faraday was so big, he gave lectures, and he was really good at lecturing in chemistry. He made chemistry popular with even wealthy people. They thought it was kind of neat. They'd come and see his lectures. Anyway, so Faraday got to be in a lab. He got to be in a lab and have all this equipment and stuff like that, and he learned from Sir Humphrey Davy. And you'll find out later, I don't know if it might be in a video later, we'll see. Sir Humphrey Davy, they would travel all over Europe and give chemistry demonstration, and Faraday would go with them. But for whatever reason, the wife seemed to be kind of like more elitist, like, we're here, and I know who you are, I know where you came from. And she never, ever treated Faraday as if he was a science kind of a person. He's just like you're a servant. You can't sleep there. You go sleep somewhere else. And so even that didn't stop him. And anyway, later I'll tell you about some things he did. I have some little demonstrations today, and I'd like you to at least take a little sketch, some little notes on. We'll talk about some of the things he did, and then we'll get into his work with the Candle Lab. Okay. Well, one thing he did is he worked with magnets and electricity. And he actually changed the world. By the time today's over, I'm hoping to tell you what are some things that he did that your world was changed today. Even today, the entire world was changed by some of his discoveries. Now that's hard to do, you know. It's hard to change the world. So let's take a look at some things he did. I have here's what I have. First of all, I'll show you a magnet, and you're basically a magnet, just a bar magnet. And so what I'm going to do here is just lay it there, and you say, well, that's nice. Thank you for showing me a magnet. And so why do I want to do this? Why do I want to show you about a magnet? Because, and I don't know if you do this in middle school. I don't know exactly whether they spend it. Do you guys spend any time with electricity or magnetism?
Magnetism, I think.
A little bit of magnetism? What do you do with magnets? Do you remember?
We had like a bag, and we had like a magnet, like magnets inside of it, magnetic, like files.
Oh, filings? They call it iron filings?
Mm-hmm.
Okay. You know, a lot of people, when they see that word, they'll say iron fillings because they can't believe it's filings. But it actually is as if you filed a piece of iron, and that's the stuff that comes off. They really is called iron filings. Well, I have something like that. The only thing I don't like about iron filings, you know, a little bit of moisture in the air, and they kind of rusting, and your hand gets all dirty and stuff like that. So what we have here is this is stainless steel. Of course, steel is an alloy. It's mainly iron, but we have chromium mixed with it. So chromium and iron make stainless steel. And what I'm going to do is, instead of iron filings, I'm going to put these stainless steel filings and just kind of tap it out. And I'm not telling these little pieces of steel, I'm not telling them what to do. I'm just going to let them tap, and you go where you want. There you go. Just go where you want there. Why are you going there? I didn't tell you to go there. What do you notice? Now, these little pieces of iron then, why are you lined up like that, and then like that, and like, why didn't you go like this? Something's forcing them. They're forcing those little pieces of iron to line up, aren't they? And these are called lines of force. Now, scientists were aware of that. They were aware that magnets have these things called lines of force. And I know you've done that probably as a kid. You ever have two magnets, you put them together, and they can either push or pull, can't they? I think that's amazing. How can a magnet push and pull? How does this magnet even know the other magnet's there? Hey, push, flip it around, pull, what? How does that happen? Well, anyway, these are called lines of force. And let me go ahead and start this again now. Amen. Okay. Now, what would happen if I were to put two magnets together? And these aren't as powerful as I'd like them to be. But I'm going to try to put two magnets together. We'll do it again. Now, what I've done here is put opposite sides of a magnet kit together. So it'd be like north and north or south and south. Oh, too much there. And if you wanted to, I got to hurry a little bit here, but if you took your time and really tapped these out, you could get a really good picture here of what's going on. All right, what do you see?
Yeah.
So we see that there seems to be kind of like what we saw before, wasn't it? And kind of like we saw before, but what's this? It's like a desert almost. And it's like nothing there. So it's almost like the lines of force have been, instead of going out like they did, they're kind of being repelled, like something's being repelled. And, okay, so again, it's not that Faraday, other scientists were aware of this thing. They were aware that there are these things called lines of force. But what good is that? What good was that? And I'm going to show you another one. By the way, I don't think I'm going to pass this out. I will tell you that, remember neodymium? These are neodymium alloy magnets, and I've had them for about 15 years. I had to school buy them, and they're not in great shape, but they're okay. And you know why the little chips off? Because people who think they're really strong and everything, they think, oh, I can make sure they go together and they won't smack them together, and they don't. And then you get your finger smacked and you pinch and anyway. So I don't know if I'm going to pass around, but after class, if you think you want to come up here and look at these, you can. If you think you can take these apart, number one, that's fine. And then if you think you can put the opposite ends together and have them touch, I'd like to see that too. But these are very, very powerful magnets, and they're called neodymium alloy magnets. So I just want to show it to you. They are okay. Wait. Let's show it to you. So here's what Faraday. Where did Faraday become famous? What did he get famous for? And light's in there. But let me tell you what he did here, and I'll show you. I forgot to show you this. This right here is a neat little device, and it's just like a little handle. See it? And it's got a tiny little bar magnet in it, and the bar magnet can spin this way or it can spin this way. So you can spin any way you want. So if I were to take one of these magnets here, just like the iron filings told me what was going on visually, what if I took this? And can you see this? Okay, take a look at that. Can you see there? Can you see that? Now, watch that little magnet, and watch what it does. I'm not doing that. It's like, well, you're making it do that. No, I'm not. And so you actually, if you want in 3 dimensions, if you want to look at a magnetic field in 3 dimensions, you can see that. If I took these neodymiums, I wonder how far out it would start affecting. There, out here. You see that? So that magnetic field's reaching out pretty far, isn't it? So there's another little device that's kind of neat. But I want to show you what Faraday discovered and what changed the world. Here's what changed the world. Does everybody know? Okay, you know what a compass is? Okay. So a compass, if I put a magnet next to it, it's going to point toward the magnet because the magnet is close enough that its magnetic field will force that thing to line up, just like the little pieces of steel did, didn't it? But right now, what if I don't put any magnets next to it? Uh-oh. As a matter of fact, that's what I need to do is I need to get all the magnets away. What if I don't put any magnets around it? Now, where are you pointing? And God didn't have to do this, but God gave this planet. Not all planets have magnetic fields. Okay, we have a magnetic field, and underneath the crust, there's these. A lot of the magma is moving. They think the moving magma, the iron in there, is causing a magnetic field. And it just so happens that we have this thing called the North Pole and the South Pole, right? That tells you where the planet rotates. But the magnetic North Pole is actually not exactly up there. It's about 1,000 miles south of the North Pole. But it's close enough that our compasses still sort of point toward north. You get it? If I got close to the North Pole, it would point to the magnetic North Pole, okay? But for right now, it's close enough that when I put a compass there, it'll tell me where north is. All right. So the magnetic field of the Earth is now more powerful than that magnet that I moved way over here. And this is pointing like that. So what he did is he didn't have one of these. They had other kind of batteries or thing. And he's going to put electricity in a wire. And so you let electricity run through a wire. So what? People have done that many times. So you let electricity run through a wire. What's supposed to happen? So I'll see if I can show you here. I'm going to try to get my hand out of the way. I'm going to try to, I'll tell you what, let me do it this way. That'll make it easier. So I'll tell you what, I'll line it up with the wire, and then you'll see something happen. I'm hoping it's going to happen. This battery's not too old, I don't think. Okay, so wait, what happened here?
The compass pointer started spinning.
See, I didn't bring a magnet in there, but I brought electricity. And what he discovered is that electricity can produce what around it? A magnetic field. And then he went on and he found that a magnetic field, if you run wire through it, let's say you have a horseshoe magnet, you just run wire through it. Guess what you can make? If electricity can make a magnetic field, what kind of magnetic field if you run wire through it? Electricity. He changed the world because that eventually made what they call electric generators and electric motors. Now, do you know where we're getting our electricity right now? Duke Power. Where are they getting it? They have generators, big ones, and they're magnets and wires, and they make them turn. And when they turn, they produce electricity. It changed the world, this discovery. Now, even though I want to concentrate on the things he did with the candle, I want to make sure you understand this person who had very little education but a lot of curiosity. He went on to do great, great things. So I'll show you here here it is. This right here is a generator, okay? And I don't know if you can see it or not. They made it so you can kind of see through this. Can you see through that little handle there? You see that thing right there? Okay. That thing right there is very similar to this. And I took one of these apart. And I don't know if you've ever done this. When I was a kid, I thought it was always neat to have, you guys don't do this kind of stuff. Have you ever had electric motors? Anybody ever had an electric motor and you hook a battery up to it? And have you ever done that? You have? I'm impressed. I took it apart, and guess what you see in there? You see a bunch of wires. And when you hook electricity to it, it makes electromagnets. So you have magnetism and wire. You got it? And so this is an electric motor. Well, if you put it in here, let me show you what happens. Come on, keep going. Whoops, sorry. Uh-oh, this is something's going to happen now. Okay, so if I provide the electricity, it'll make a magnetic field, which will make electromagnets, and I can turn electrical energy into mechanical energy. And the electric motor changed the world too. See that? Now, what's interesting, let's go ahead and switch these. What if I switch these? What happens here? So I want to reverse. Now, I think one of the most fascinating things, though, is what if I decide to do something a little differently? What if I decide that you can't see that very well, can you? How about that? Can you see that? What if I decide to put the mechanical energy in? What if I put the mechanical energy in? My electric motor is going to be turned into a what? Well, kind of a battery. It starts with a G. I'm making electricity. What's it called? A generator. That's what Faraday's discovery did. You put the electricity in, and I'll make you mechanical energy like a motor. But what if I put the mechanical energy in? What can you make? Electricity. And that's how we make electricity around the whole world. The whole world makes electricity, except they're big ones, aren't they? They're big generators. And so it did change the world. I want to just tell you how it's impressive. I got one of these little kits for my grandson. It worked all right, but not great. They always tell you they're going to work great, but you're supposed to get a 2-liter bottle. You're supposed to put it on there and then wait for a windy day. And then it had to be really windy, like really windy. And you had to make sure the bottle blew away. That's how windy it was. But essentially, they have a little electric motor here. And when the wind would blow, here's what they wanted you to see. So if it blew really hard, that was supposed to happen. Anyway, that's the little thing. So that's the same thing where the wind would provide the mechanical energy, and it would turn this into a generator, and it would generate enough electricity to make the light bulb come on. So Faraday's discoveries changed the world. Now, what he did here, let's go ahead and, you have your handout sheet with you? We'll read just a little bit about Faraday here. Michael Faraday is born, the son of a blacksmith, born in Newington Butts near London, 1791. He began his life as an errand boy to a bookbinder and a stationer who he later was bound apprentice. After 8 years of binding books, that means he read a lot of books too, he was engaged by Sir Humphrey Davy as his lab assistant at the Royal Institute. He traveled extensively in the continent and with his master, and also saw very, very other famous scientists in Europe. Shortly after he returned to the Royal Institute, he began making contributions of his own. The first paper appeared in 1860. He became the director of the laboratory in 1825, professor of chemistry in 1833, rising rapidly through a number of important discoveries, most distinguished position. Now, it said he was working at too great a pressure. 1841, his health gave way, so that 3 years he couldn't do any work at all. He was so intense for a long time. He recovered, however, and made some of his most important discoveries after this interruption, and he was offered, but declined, the presidency of both the Royal Society and the Royal Institute. He was actually belonged to a Christian sect. It was a church that they didn't believe that glory should go to God, and that they said you can become the president. Like Isaac Newton was the president of the Royal Society. You could be like Newton. And he said he declined. He declined it. He still went ahead and did a lot of work, but he didn't want to be elevated. As him, he didn't want to be elevated. Today, it seems like that's what a lot of people say. Hey, what do you want to do when you grow up? I want to be a rock star. I want to be this. They want their name to be elevated. And that's kind of the way you live, and that's the world you live in, and it's easy to succumb to that, didn't it? I remember in one passage in the Bible, what did Satan tell Jesus? What did he tell him? He took him on a tall mountain. What did he say? You can have what? You can have all this. It'll be under your control. He was trying to elevate him, wasn't he? And so the group he belonged to, they really truly believed that the glory should go to God, not to humans. He still wanted to do a lot of good stuff, didn't he? But he didn't want to be elevated and say, look at me, look at me. Next, it was a characteristic of Faraday's devotion to the enlargement of the bounds of human knowledge that on his discovery of magneto electricity, he abandoned the commercial work by which he had added to a small salary in order to reserve all of his energies for research. So there were people willing to pay him money to become like a director or something. He said no, he just really liked doing research. The financial loss was in part made up by a pension later. He discovered so many things that made England a lot of money. People in England, a lot of companies, they made a lot of money off his discoveries, a lot. And it was offered money, and he declined it. Now later, when he got really old, the government said, well, we're going to give you this much a month, and there's a house you can live in until you die. And he did accept that. But anyway, it said here, I'm going to skip the next paragraph. You can do it if you want. Faraday's parents were a member of the, it says obscure, but religious domination of the Sandemanians. And Faraday himself, shortly after his marriage at the age of 30, joined the same sect to which he adhered to his death. Religion and science he kept strictly apart, believing that the data and science were an entirely different nature from the direct communication between God and the soul in which his religious faith is based. The discoveries made by Faraday were so numerous and often demand such a detail of chemistry and physics that they could be understood. It's impossible to attempt to describe or even enumerate them here. Among the most important are the discovery of magnetoelectric induction, the law of electrochemical decomposition, magnetization of light, and diamagnetism. You saw there that even though people realized how intelligent he was and how much he discovered, he didn't have the math background to prove it, but he had the feeling, and all the experiments based him. He said, I think light is made of electricity and magnetism at the same time. And that was ridiculous. Everybody laughed at that. Light made of magnetism? What are you talking about? When I turn the light on, I don't see magnets happening. But he couldn't prove it. And if you ever look up who actually discovered the formula, the mathematical equation for light, how light is generated, what was that person's name? Do you remember?
Max.
Somebody said it. What was it?
Max.
Yeah, his name is James Clerk Maxwell. And you look it up, it'll have Maxwell's equation for light. Well, Maxwell became a friend of his, and he did some of the math, and he actually proved it. He wanted to go talk to him and say, mathematically, I can prove that you were correct. And even Einstein, he understood that the nature of light had a great deal to do with the stuff that Einstein was working on. Okay, let's go to the next one. I already read this one, this little paragraph to you before. And I do want to mention that he didn't have to do this, but he wanted to have young people come in. He wanted them to come to the Royal Institute, where all the famous lectures are given by famous scientists. And he brought them in, and he brought them in at Christmas, and they were called Faraday's Christmas Lectures on the Candle. Anyway, I'm going to just read one, and then we're going to finish for today. This is the beginning of it. I purpose in return for the honor you do us by coming to see us here at our proceedings here to bring you before you, in the course of these lectures, the chemical history of the candle. I have taken on this subject on a former occasion, and were it left to my own will, I should prefer to repeat it almost every year. So abundant is the interest that attaches itself to the subject, so wonderful are the varieties of outlet for which it offers into the various departments of philosophy, which is science. And then I already mentioned that other comment, and I think that's a big statement he made. Anyway, what I'd like to do is, if you'll bring your candle on Tuesday, we'll kind of go over what it is you're supposed to do, and I need to go over the safety directions. This one does have danger. This lab is much more dangerous than the popcorn lab. You get that? We're going to have like 17 candles going and 17 people acting like scientists that want to do little experiments. We have to all be on the same page as far as safety. Got that? So, anyway, I've done this for many, many years, 28 years, and I want to keep doing it, and I want you to do it. So, if you didn't bring your candle today, you got to try to remember it after a 3-day weekend on Tuesday. All right, got any questions for me? All right, well, thank you very much. The very short class, but anybody want to see the neodymium magnets? Now, if you get hurt, you can't say anything. Okay, I'm going to tell you that you'll get your finger snapped here. All right, come over here. All right, so you can do what you want. You can pull them apart, and then you're going to say, and I'll give you a hint. My hint is I put my hands next to my body. That helps me. So I can get them apart. Okay? Now, I know what you're going to think here. If I give you this other one, do not put your fingers where they'll get snapped. No. Now, they don't want them to snap together. That's how all these chips happen. See that? So you're going to have to try to put them together without them smacking each other. So you better, it's going to take more than that. It's going to take more than that. You better, okay. Can you get them apart?
Okay, but you really think I know that?
Watch your fingers. And you're sure.
She really nailed it too. She said she
See if you can turn them around, see if you can get them to touch. Watch out, they'll flip each other. They'll flip on you. Okay. They'll flip right around. Flip one up. No, yeah, just flip. There you go. Let's see if you can put them together. Now, they'll flip right out of your hand. There you go.
Let me try.
Okay. Yeah, that's good. Well, yeah, careful. Okay. Careful.
So
I know what you're thinking. They're going to come right out of your hand, or you're going to snap your fingers. No, that's not going to work. Oh, that's the opposite. Okay, good.
wow, these are stronger
Isn't it
than
amazing that they look like rocks. They look like rocks, and there's some unbelievable force.
So would those just be like, would there be like on a mountainside or something, and somebody?
No, they had to make these, but they took, I don't know what all the metals, neodymium is one of the metals.
That's crazy.
But not every metal is magnetic.
Oh no. Well, we're gonna be